Before I can demonstrate the true use of polymorphism, I want to make sure that the draw methods work for both the circle class and the rectangle class. And by doing that, we'll get to see what polymorphism isn't. So let's start out by creating two objects. I'll tell you what, let's make three objects. We have a shape object, a circle object, and a rectangle object. And now let's call the draw methods for each of those. And that should be good. Let's save the program. Now let's compile it. Now let's run it. Let's make one correction here. Let's add a print line between each call so that we get everything on a single line. There we go. All right, let's save it again. Let's compile and let's run. Drawing shape at coordinates 2, 3. Drawing a circle at x equals 10, y equals 20 with radius of 5. Drawing rectangle at x 50, y 100 with 10, height 20. And we also didn't need that system out print line between circle and rectangle. Now, this is not an example of polymorphism because the draw method is directly attached to the S1 object, which is a shape object. So when the compiler is trying to figure out what draw method to use, it doesn't have to look at anything other than what object it's connected to. So it knows automatically to use the draw method for a shape. Just like in the second example, draw for C1 knows to pull the draw method for a circle object. And this last example, draw for R1, the compiler knows that it needs to get the draw method for a rectangle object. The idea behind polymorphism is that we could have some sort of ambiguous reference to an object and then call draw on that object and have the compiler figure out which one is necessary. I'm going to demonstrate how that works in the next lesson when we build an array list of shapes and then call the draw method on the array list objects. And that'll give you a good idea of how polymorphism works. So we're going to move on to that next lesson now.